work done by conservative forces and by non-conservative forces. Let us again consider the block being moved from a height above the ground to the surface of the ground. The velocity of the block at the start and at the end are both 0. The block has two forces acting on it, the force of gravity in the downward direction and the applied force in the upward direction. The work done by gravity can be found easily. Wfg equals mg times h times 1 equals mgh. Let us also calculate the potential energy of the body at points A and B. We take the ground as the reference point. EP at A equals mgh. EP at B equals mg times 0 equals 0. The change in potential energy in going from A to B is delta EP equals EP at B minus EP at A equals 0 minus mgh equals negative mgh. Combining equations 1 and 2, Wfg equals negative delta EP. More generally, W conservative equals negative delta EP. This is a very important result. If there are conservative forces and non-conservative forces present, we can write the net work done or the total work done in terms of the two. W net equals W conservative plus W non-conservative. The applied force is a non-conservative force. We also know from the work energy theorem that the net work done on a body is the change in kinetic energy. W net equals delta Ek. Combining 3, 4 and 5, we can write W net equals W conservative plus W non-conservative. Delta Ek equals negative delta Ep plus W non-conservative. W non-conservative equals delta Ek plus delta Ep. The total work done by non-conservative forces is the sum of the change in the kinetic energy and the change in the gravitational potential energy. This is another important result. The relationship can be rewritten as W non-conservative equals Ek final minus Ek initial plus Ep final minus Ep initial. Rearranging the terms, Ek initial plus Ep initial plus W non-conservative equals Ek final plus Ep final. Emec initial plus W non-conservative equals Emec final. This is the conservation of energy in the presence of dissipative forces. We can see that if W non-conservative is 0, the right-hand side of the equation will also be 0. In the absence of non-conservative forces, the change in mechanical energy will be 0. In other words, mechanical energy is conserved.
Starting to feel it? Now go master it with Maski.